Good morning, everyone. Today, I will be presenting on the future of heritage archives, AI-based method for recording and access. My name is Jong Lee. I'm affiliated to Department of Digital Heritage in Korea National University of Heritage. Let me introduce myself briefly. I'm associate professor at KNUH, and I'm director of Computer Center at my school, and I also member of E-commerce Korea. My research background is based on heritage study in bachelor degree, and I finished my master's degree and PhD in engineering at KAIST. Okay, I want to introduce my school briefly. My school is specialized in the heritage studies and education, and my school is divided to college and graduate school. And at the graduate school of Korea Heritage, department is divided to traditional technology such as conservation and restoration, and digital heritage technology for heritage industry. Department of Digital Heritage is based on convergence of heritage expertise and digital technology. We operate the graduate school course that trains professionals who can produce, manage, preserve, and dissemination digital heritage in the cultural industry. And I'm managing Heritage Information Lab. We research heritage archives, education, and exhibition content. We are developing digital curation and information visualization, intelligent platform, and AI storytelling with museums and archives. We also are carrying out international projects such as construction of a digital heritage center in Egypt and the design of a digital heritage curriculum in Saudi Arabia. Our research part is heritage information research. Our research encompasses several interconnected fields. We conduct heritage information research and data analytics and information visualization and AI-based digital service. Our work spans digital heritage curation, digital archiving, and digital humanities and human-computer interaction. You can see the digital heritage curation process from creation and acquisition and processing, refinement, and storage and management and utilization and sharing. And final part is about the reuse of digital heritage. First, I want to introduce the concept and importance of digital heritage. Museums and heritage organizations today face two critical challenges. There are an exponential growth in the quantity of digital data, and second is about the purposes and types of data creation have become increasingly diversified. This combination creates a complex landscape of digital information that requires sophisticated management approaches. For example, museums and heritage organizations are facing an explosion of data of various types and formats. This includes 3D objects such and XRF data and reflectance transform imaging and gigapixel data per high resolution image. And also they deal with the infrared spectroscopy and computed tomography for heritage conservation. Each of these technologies generates unique data sets that requires specialized handling and preservation method. Another challenge is the change of value of heritage. Nowadays, the heritage is divided to cultural heritage and natural heritage and intangible heritage. Preservation and management and utilization of digital heritage varies by type of heritage. And also, it is increasing value of the relationship between various heritage types under the comprehensive value of heritage. So, for the digital heritage, we have to connect the value of various heritage types. We can see the definition of digital heritage, which is defined by UNESCO. They say the digital heritage consists of unique resources of human knowledge and expression. It embraces cultural, education, and scientific and administrative resources, as well as technical and legal and medical and other kinds of information created digitally or converted into digital form from existing analog resources. And digital heritage can be divided to two categories. First of all, there are born digital heritage, which includes game contents and virtual and augmented reality content and media art. Second, there is the digitized heritage, which encompasses scanned text and 3D architectural heritage and scientific images. Different types of digital heritage require different preservation and management and utilization approaches and strategies. As you know, nowadays, there are many increasement of born digital heritage in digital era. I want to talk about why the digital archive is necessary and important nowadays. Digital archive is a system for storing and maintaining and accessing digitized materials. And digital archiving is activity about the long-term management of a digital object deemed to have enduring value. And the activity of selecting valuable digital resources and preserving and managing their content and functionality and making them accessible for the long term is digital archiving's important aspect. We also talk about the digital curation. Digital curation is actively managing and preserving data and adding value to it so that it can be used and reused now and in the future. We can see digital curation life cycle model. It is very important around the world. And we can talk about the data conceptualization and create or receive and appraise and select, ingest and preservation action and store and access, use and reuse, and transform. According to this life cycle, we have to make the strategy to preserve and management and utilization of digital heritage data. Now we have to talk about the importance of digital heritage. Digital heritage can revitalize the national heritage industry and international exchanges. It revitalizes culture and media industry and local economies by building immersive contents based on heritage data and information. And it can promote the international exchanges and ODA projects through digital heritage in Korea. In the second session, I want to talk about the current status of digital archiving of heritage. For this, the digital heritage curation process involves multiple stakeholders and stages. It begins with creation and acquisition and processing and refinement and storage and management and utilization and sharing. And it can be reused by public activities. We can talk about the digital heritageization. In this process, data can be transformed and used, and simultaneously, the heritage value can be changed and made by professionals and public. So, for the digital heritage archiving, we have to archive the data and value. For the digital heritage creation, we employ several key technologies. It's about the three-dimensional scanning. This technology is for recording the surface, form, and color of artifacts in 3 dimensions. And next one is RTI. RTI is reflectance transformed imaging that contributes to precise recording and preservation of detailed information about artifacts. Final one is the gigapixel imaging to digitize paintings in ultra-high resolution to see cracks and brush stroke and fine details. For the intangible cultural heritage document, various document technology and analytic techniques can be used. Motion capture technology is the technology which records the movement of people or objects as digital data and precisely measures body movement such as motion and posture through infrared sensor. Volumetric technology is a little different with motion capture technology. They use 360-degree angle cameras at any time, which is great for intangible heritage preserving. And AI analytics technology can be used for pose extraction and motion classification and creation and reconstruction. For the natural heritage such as the specimen, we can talk about 3D scanning technology, such as documentation activity, including recording the biological and morphological and environmental context of specimen. We can document the specimen's appearance and texture and color using high-resolution equipment, including fur and feather. We can collect anatomical data using CT scans and X-rays to record the internal structure of specimens. And we used AI-powered geometry prediction and data platform to reconstruct hidden or destroyed part of a specimen. As you see, recent digital heritage technology is focused on digital heritage creation and documents. Another example is about the documentation of architectures. You can see the Notre Dame Cathedral and Temple of Palmyra in Syria. In Korea, Sungremun Gate is created by the BIM technology, and in Japan, Shuri Castle is reconstructed by the structure from motion algorithm and extracted 3D geometry data from overlapping images. For the digital heritage processing and refinement, we can see the scan to BIM technology, which convert the point cloud data to the BIM data, and they can use PointNet++ model algorithm allow you to build architectural elements such as walls and columns and ceilings. And convolution neural network and graph neural network can be used to reconstruct the distorted architectures. For the documentary heritage, we can see several key technologies such as OCR technology, which automatically recognize characters in images and convert them into digital text. And we can see the natural language process, which can digitize and analyze massive text from documents using NLP and text mining technologies. And network analytics can show the relationships between the historical elements. And topping modeling can be used to digitize local manuscripts, analyzing them for keywords and themes to discover topics. In the archaeology, they can use the drawing automation technology, which can quickly design the drawings and that were previously created by hand, and increasing accuracy and reduce man hours. And they use cloud-based collaboration and AI-powered data platform to integrate the archaeological data. So I want to talk about the future of digital archiving of heritage based on my projects and other famous projects. I want to talk about the Digital Heritage Intelligence Platform project. It is an AI-based digital heritage platform that standardizes these digital cultural heritage data and supports specialized heritage service and globally competitive content creation. It includes the establishment of standards for the generation, transformation, and processing, and analyzing and visualization of digital heritage data, such as artifact data, and exhibition data, and conservation data, and digital assets. For this data platform, we define the data structure and data elements, which are project, work, instance, item, structures. Work is about the artifact information, and instance is digitized process information, and item is the digital data. They can have interconnected relationships. So in the platform, we can conclude and propose the conclusion of searching with our interconnected informations. This is our platform, the digital health intelligence platform. Users can search the artifact information and conservation information, and they can see the connections between informations. And I want to show our labs, the information visualization project process. First one is archive information visualization. Our heritage archive information visualization system focuses on Joseon Dynasty paintings. The system accumulates patterns and icon information and descriptive information and research materials and video information on Joseon Dynasty painting. It develops data upload and metadata editing tools and visualization modules. It supports visualization of artifacts through diverse perspectives based on artist and location and subject keywords. You can see the various information types with the dynamic criteria such as the artist and the locations. It is our 3 years project, and it was finished last year. From now on, I want to introduce our recent project, which is connected past projects for information visualization. Hello is the integrated word, the heritage and flow. You can see the searching flow with this project, and you can access the digital heritage data using the generative AI technologies. There are 2 modules to show the data flow. First one is data connection and data searching process in the 3D environment. And next one is the information visualization based on the generative AI. users can access to existing heritage information sites with our system. And next one is to access the digital heritage data. Users can make their virtual artifact with generative AI based on our data set and algorithms. They can select the era and the usage and the texture and making the virtual things, and system can recommend the similar one which user make. And this system connect another digital curation platform to restore the heritage information and exhibition information and conservation data. This system is application of ontology-based data structure and data standards. It visualizes the contextual relationships within 3D cultural heritage knowledge network. It enables the autonomous exploration by both non-experts and semi-experts through generative AI. It provides information on actual artifacts and resources most similar to user-generated artifacts. For this system, we collected data from 200,000 collections. In the data process stage, data from 190,000 artifacts were refined to extract key metadata attributes such as era, material, and purpose, and nationality. The data model was designed with a 4-layer structure, work, project, instance, and items. To implement metadata relationships, we utilized the BERT model based on the transformer architecture to extract semantic information of artifact description text and generate the similarity matrix between metadata attributes through cosine NOE index algorithm. Next one is the AI-based storytelling. It secures 174 types of icons and 45,000 tagging data through tagging of patterns and icons in calligraphy and paintings. It derives additional non-visual information such as emotional information from cultural heritage for enhance the non-visual storytelling elements. Final output is about the recommendation storylines based on storytelling topics are determined based on the visitor's profile. We can talk about the future of the intangible cultural heritage archive. It is the memory twin for preserve the intangible cultural heritage. We present example of documenting ICH using cutting-edge technologies such as motion capture and volumetric video and XR, VR, and multisensory data. We emphasize the importance of ensuring academic reproducibility and transparency through integrated records of data and metadata and paradata, which is related with interpretation. We reflect social meaning, memory, storytelling, and community engagement in digital documentation and exploring relationships through knowledge graph-based visualization. For the architectural heritage archiving, we can recommend the AI-driven platform for virtual reconstruction of cultural heritage. It establishes a collaborative digital preservation and reconstruction platform for heritage sites that have only partially remained. and fragment. By adopting a data, metadata, and metadata structure, the platform will ensure transparency in the process of evidence and interpretation and hypothesis. We can enhance the data platform of National Archive, and we can make the context-oriented search environment and fostering the international collaborative ecosystem. Final one is about the natural heritage, the archiving. It is not our example. I can introduce the Lepic Anadol's digital art. The name is Machine Hallucination Project. Uses the AI algorithm to create a loom. Digital art that visually reconstructs natural heritage image data. And he developed the Large Natural Model, LNM, the world's first nature-specific open-source generative AI model. Next one is hyperrealistic access for preservation of natural heritage. It creates an SL library containing the weather, seasons, and sounds, and terrain, and soil, and more for use in films, and dramas, and games, and more. It records the biological, and morphological, and environmental context of the animal specimens. It is a little different, a little problem. It is also the Lepic Anadol's works, which I mentioned. His data includes the material from Smithsonian and Natural History Museum in London, as well as the photos and sounds and 3D scans from 16 rainforests around the world. In this work, he calls the attention to importance of ecosystem health to sustainability of the planet. And users can explore the possibility of advanced technology to record and appreciate nature. Yeah, it's real final presentation. We can talk about the utilization of standardized framework for integrated use of digital images. We can develop open API supporting sharing, zooming, and comparison and annotation of high-resolution images. And we can propose a standardized model for data exchange between Korea, cultural institution, and European, and Asian, and Chinese, and Japanese data exchange model for cultural exchanges. Okay, thank you for attending my presentation. Thank you.